1.
These are notes for addition, subtraction, and polynomials. For many of you, you'll be doing this right after your exam over systems. So we're going to go through some different problems here and then talk about the rest of them in class. So the most important word you have to know here is like terms. And so for like terms, we're looking for the same variable, combination, power, and the same exponent. Okay, so there's a few examples here. And so it says each table below contains like terms. Make up your own example for the last box. So the terms here are all x. So we have an x, an x, an x. You could do anything, 7x, negative 5x, 3x, any fraction, any of that would work. Second one, all numbers. Notice there's no variable here. It's really x to the 0 power. So any number here would do. Make up whatever you want. These are all y squareds. So 15y squared, 20y squared, whatever you decide to do. Notice this is a combination of x's and y's. So 6xy. And the last one is a combination of a to the second and b. Again, what we're worried about is the number in front being different. That's called the coefficient. And that's not a new term, but maybe we don't use it all the time as much as we should. Okay, so it says circle the term that does not belong. The one's not a like term. So in A, I have a b to the third, a b to the third. That's not b to the third. All the rest are b to the third. M squared n cubed. M cubed n squared. So I got to see if it's like one of these. M cubed n squared. So these are the same. Same. So that one is the odd man out. RS, R squared, S squared, RS, 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 odd. You kind of get the gist here. A to the fourth, B to the third, C squared. Notice I'm not even looking at the number in front. The number in front does not matter. Coefficient does not matter one bit. I'm just looking at the combinations. So I have A4, B3, C2. This is the one that's the odd man out. Okay, and you've seen me in class write this a lot. CLT. The only thing is we haven't used really any exponents. Combining like terms after you distribute before you solve. And one of the strategies we did to combine like terms, and we're going to do the same thing again with polynomials, is to make marks underneath the like terms. So sometimes I do that, or put a box around the like terms because we're worried about the coefficients with a like term so we can combine them together. Same thing with equations. The first unit we did this year, some of you struggled because you tried to solve it right here before you combine like terms. Okay, so here's what we're going to be doing. We're not solving anything. We're simplifying things for these notes. And so what I'm going to do is look at the operator here. If it's a plus, the parentheses don't really mean anything because if I distribute, this is like distributing a plus 1. Everything is the same. So now I'm just going to look for like terms. So here is negative 2x squared. And so I'm going to single underline any other x squared. So I have negative 2 and negative 7, which is negative 9x squared. Then I have 5x to the third and 1x to the third. 5 plus 1, 6x to the third. And you can do a triple underline here. 8x to the fourth, 4x to the fourth is 12x to the fourth. That's it. These are not like terms. You can't combine this down to one. We're not trying to get it down to one number at the end. Okay, things can get a little tricky is when you have subtraction, just like always. Treat subtraction like distribution of a negative 1. So I'm going to distribute first. I'm going to rewrite these. Then I'm going to distribute a negative 1. So this is negative 6x to the fourth plus 7 minus 7x to the third. And now I'm going to go through and mark my like terms. So I have a 6, which is just a constant, and 7. Negative 6 and positive 7 is 1. I'm going to write it over here. We usually start at the highest power and go to the lowest. So I'm going to now look for the highest power. So I have x to the fourth, x to the fourth. Notice how I included the coefficient when I made that box around it. So this is negative 1 and negative 6, which is negative 7x to the fourth. Next would be x to the third. I'm going to circle those. So -7 and -7 is -14. And then because I've marked them up, I don't miss any extra at the end. That's my answer. Okay. I'm going to skip over number 3. I'll let you. Actually, I'm going to skip over number 4. I'll let you do that one. I'm going to do number 3 because there's some weird combinations here. So again, I have this minus, so I'm going to distribute this -1. Rewrite the first set. You don't have to do that. It just makes it easier to. The only place you really make mistakes here is when you lose your like terms. You lose some terms. So I have positive 7xy, negative 6x to the 4th, and negative 7xy to the 4th. So double check, positive, negative, negative. Now I can go ahead and find my like terms. I'm just going to start here. Beginning, there's negative x to the 4th. That's the same as -1. And negative 6x to the 4th. That gives me negative 7x to the 4th. 3xy to the 4th. So I'm going to underline that one and look for any other xy to the 4th. So there's an xy to the 4th. 3 plus -7 is -4xy to the 4th. And then I have -5xy and 7xy. -5 plus 7 is 2. If you're just careful in how you mark your paper, these will be the easiest problems you ever did. Okay. To do the last ones here, you're going to see some applications of like terms. Remember, perimeter. Think about your favorite police show. We have the perimeter of the building surrounded. That would be the outside if you are adding around the outside. So the perimeter of any shape would be to add up the outside. We've done this with rectangles with our formula. You had a formula for it, but you don't really need the formula because you know that you're just adding all of the sides together. So I'll show you on the rectangle. 3x plus 4 plus 2x minus 1 plus 3x plus 4 plus 2x minus 1. That's where there's 2 of them here and 2 of them here. That's where the 2L plus 2W business comes in. Let's go ahead and combine like terms. So 3x, 2x, 3x, 2x. That's 10x. 4 minus 1 plus 4 minus 1. So that's 3, 7, 6. Now, when you don't have higher powers, you could just look around this thing and add them on here. You wouldn't have to list it out, but showing you that's the same. So there are Khan Academy assignments now that go along with the polynomials. And if you get stuck, don't forget the video hints on there because it might extend your learning a little bit.